Hello everyone, in this video I'm going to take the derivative of exponential function 5 to the square root of 2x. So let's go ahead and work on this problem. So we have this function. I'm going to write it down. Y equals 5 raised to square root of 2x. Okay, so 5 is the base of this function and square root of 2x is the exponent. So I'm going to use one of the natural log property here. So we have e to the ln of a equals a. So e to the ln of 5 equals 5. So for this 5, I'm going to substitute e ln of 5, e to the ln of 5. So y equals e to the ln of 5, and then that's raised to square root of 2x. Okay. Now I'm going to use a property of exponents. So if we have a raised to the m power, and that's raised to the n power, equals a to the m times n. So we basically multiply the exponents. So similarly, we have e raised to the ln of 5, and then whole quantity is raised to the square root of 2x. So we can just multiply these two exponents together by using the property of exponents. So y equals, we have e to the ln of 5 times square root of 2x. Okay, so in next step, I'm going to take the derivative of this. So we get dy over dx equals d over dx of e to the ln of 5 times square root of 2x. Okay. So now we have this e to the something function. We want to take the derivative of that. So we're going to apply the chain rule here. So first, the derivative of e to the x equals e to the x. So similarly, a derivative of e to the u, which is some function, is going to be e to the u times du over dx. So that is important to know. Okay, now let's go ahead and apply this chain rule here. So we get dy over dx equals, when we take the derivative of this, we get e to the u. So this is our u equals ln of 5 times square root of 2x. Okay, so we get e to the u, e to the ln of 5 times square root of 2x times the derivative of u, which would be d over dx of ln of 5 times square root of 2x. Okay, so now in the next step, we have e ln of 5 times square root of 2x. We can pull this ln of 5 out of the derivative. It's multiplying with square root of 2x. Since it's a constant, we can pull it out of the derivative. So we get ln of 5 d over dx of, for square root of 2x, I'm going to write it as 2x to the 1/2. So what I did, I substituted the exponent of the square root here. Okay. Now in the next step, dy over dx equals e to the ln of 5 times square root of 2x times ln of 5, and we can apply the chain rule here. So this is going to be 1/2 2 to the 2x to the 1/2 minus 1 times just the derivative of inside, which is just 2. Okay, so we get dy over dx equals e to the ln of 5 times square root of 2x times ln of 5 times 1/2 2x to the negative 1/2. Okay, the reason I got negative 1/2 is I subtracted 1 from 1/2, so this would turn into negative 1/2 times 2, the derivative of inside. Okay, now we can actually make a substitution for this right here. Okay, this portion right here, we know that is equal to what? Equals to 5 to the square root of 2x. Or you can leave it like that if you want to, whichever is easier for you. So I can leave it like this, and we can put, like, this 5 to the square root of 2x here because they both are equal. So either leave it like this, or you can put 5 to the square root of 2x because this thing is equal to 5 to the square root of 2x initially, okay, if we want to. So we can substitute that. So let's go ahead and simplify this. So we get dy over dx, so equals 5 to the square root of 2x times ln of 5, and this 2 cancels this 2, so we just left with 2x to the negative 1/2. Okay, so this is the final answer to this question. Hopefully this will help. If you like my video, please subscribe my channel. Thank you.